So, last night, or the night before, sometime since Monday, you should have watched the video on 4.2. So today, before we go over, I have a worksheet that I want to give you to work on today in class. Before we get to that, I want to go over two problems here on the right triangle trig type stuff, okay? So the first one that I want to go over to is I want you to find all 6 trig values of t if the cosine of t is equal to negative square root of 3 over 2 and the fact that t is somewhere between 0 and pi. Okay? Now, negative square root of 3 over 2, that should set off a little warning bell in your brain and say, this one is, or t is where? No, where is t? On the unit circle. It's on the unit circle because it's the square root of 3 over 2. Okay? You guys just memorize that stuff, you know, so it's like, oh, hey, that one's on the unit circle. Okay? So, top half, bottom half, left half, right half. Where are we restricted to? Where are we restricted to? This part right here tells me that I'm restricted to the top of the unit circle, right? Okay? And then because the cosine is negative even, I'm on the left side. Okay? So really, here, what is the radian value of t? 5 pi over 6, right? Okay. So really, we are just finding the 6 trig values that go along with a radian value of 5 pi over 6. Okay? So, we already have one of them. We already have the cosine. It was given to us as the negative square root of 3 over 2. Which means then I can find what right away? Even easier than finding the sine. I can find the secant right away. Because what's the secant of t? Can I write it as negative 2 over the square root of 3? Give you another chance? Yeah, I like that better. But I like my negatives on top rather than on the bottom. Okay? Yes, ma'am? Don't have to. Okay? If you want to, if you wanted to write it as negative 2 square roots of 3 over 3, rationalizing your denominator, that's fine. But in terms of these type of ones, Mrs. Hill and I are okay with unrationalized denominators. Okay? Alright? Now, we can go find which one? We can go now find sine. Yep. So what's the sine of t? Positive or negative 1/2? It's positive 1/2 off of my unit circle. Okay. So then what is the cosecant of t? 2 over 1 or just 2, right? Okay. Now for tangent, that's going to be y, right, or sine, which is 1/2, over x, or cosine, negative square root of 3 over 2, right? Do I like that fraction? Do I like fractions inside of my fractions? No. I don't like decimals inside of my fractions either, okay? So how do I get rid of that and make it just one fraction? Multiply by the reciprocal. So this is 1/2 times negative 2 over the square root of 3. So then what is the tangent of t? negative 1 over the square root of 3. What then is the cotangent of t? Negative square root of 3. And that, ladies and gentlemen, are the 6 trig values of t. Reciprocal of tangent.
Also, all you is what you already got.
Mm-hmm.
Okay.
Mm-hmm. Same thing with sine and cosecant, just reciprocals. Same thing with cosine and secant. Yep, everything needs a co. Okay? Now, that's all nice and good because it was on the unit circle and it was easy for us to find, right? Okay? But is every angle possible on the unit circle? No, not on our sweet 16. So, what if we have this, where theta now is an acute angle, and I'm asking you to find the 5 other trig functions of theta. Okay? Try that one. Upon just a consultation that I just had with Mrs. Hill, okay, we're changing our thinking. In terms of this one, we really want here now, we want it rationalized because on the ACT, it's rationalized. Okay? So that one should look like that. And this one should look like that. Okay? Okay? So yes, we are rationalizing our denominators. Okay? So back into this one now. Which quadrant are we in? Square root of negative square root of 3 over 3. So which angle or which quadrant are we in? We're in quadrant number 1. Okay? Because sine is positive. Okay? And it's an acute angle. Okay? So we are in quadrant number 1. So let's draw ourselves a quadrant 1 triangle. It's going to be a right triangle. Here is going to be my theta. What else do I know about said triangle? Okay, sine is the opposite side over the hypotenuse, right? Okay, so what does that tell me? But I need sides for that. So this side over here is 2, and the hypotenuse is 3. That's what the 2/3 tells me. SOHCAHTOA. Okay? Sine is opposite over hypotenuse. So that's what that tells me. Okay? If you wanted to relate it back to the unit circle, then your opposite side would be 2/3, and your hypotenuse would be 1. Okay? If you wanted to use it that way. Okay? So when I do that, then, what do we get for the missing side? What do we get for the missing side of that triangle? Missing side of this triangle is what? What you got, Ellen? Nope. I like the square root of 5. How'd you come up with the square root of 5? So 2 squared plus my missing side, we'll call my missing side b squared, right? equals 3 squared, right? So that's 4 plus b squared equals 9. So b squared equals 5. So then b equals the square root of 5. Okay. Now I can find my cosine. What's the cosine of theta? Ka. What's ka? Cosine is adjacent over hypotenuse, which what makes what, Hal? Square root of 5 over 3. Which means then that my secant is what? 3 over the square root of 5, which rationalizes into 3 square roots of 5 over 5. Okay. The sine of theta we already had, and that was 2/3, which then means the cosecant of theta is 3/2. The tangent of theta we need, and that's what? Two square roots of 5 over 5? Yep. Okay, if we think about that one, now, Eden, you're doing it a little different way than I would do it. Okay, you're doing it y over x, right? Okay, but we got the right triangle, so the tangent is really just TOA, right? Opposite over adjacent. So it's 2 over the square root of 5, which then rationalizes into 2 square roots of 5 over 5. Okay? Same thing. Yep, very much so. Yep. Okay? The cotangent then is going to be the square root of 5 over 2. With me?